Sir, is it okay now? Are you ready, Kendre sir? I think.
आता येतोय का सर?
हाँ येतोय सर, आता येतोय आवाज. Okay, shall we start now? Okay. Good afternoon, dear participants, student friends from different corners of this state. Today we are having resource person, Dr. Kendre Trambak, who is assistant professor in Department of Chemistry from Social Arts Commerce Science College, Sengao, District Hingoli. Today's resource person are going to deal with the topic nuclear chemistry. I personally and on the behalf of organizing committee welcomes Dr. Kendre sir for today's noon session to deliver his talk on nuclear chemistry. With this few words in welcome session, I hand over now this session towards Dr. Kendre sir. Kendre sir, you may proceed now.
Okay, sir. Okay, sir. Thank you for giving me such a nice opportunity for delivering a talk on nuclear chemistry. Firstly, we all are suffering from a very crucial time due to this pandemic, and we are safe in our home because the climate is very dangerous. So it is better to teach every topic through virtual mode. So the program organized by your college for the overall development of e-content as well as the material which is useful for further academic year is very nice. I personally felt it is very good practice and it is very useful for students as well as staff. So with this, may I start my topic, that is nuclear chemistry. Friends, we all know that chemistry it means atom. An atom consists of nucleus, stability, unstability, its constituent elements. All these aspects are discussed in this nuclear chemistry. Chemistry is a very versatile subject because we all know that every aspects in the world is stopped, but the chemist can't be stopped. His research, his overall practice is still continued for the development as well as for life. So chemistry is really a versatile as well as beneficial for the human welfareness. With this nuclear chemistry is a branch which deals with the study of nucleus. So in today's topic, we will see the following points that contains introduction, composition of nucleus and nuclear size, classification of nuclides, nuclear stability, release of nuclear energy, definition of radioactivity, characteristics of alpha, beta and gamma particles, group displacement law, applications of radioisotopes. These points we will discuss one by one. Firstly, introduction. The nuclear chemistry is the branch. By studying this nuclear chemistry, the student of nuclear chemistry can be applied for various companies, just like Bhabha Atomic Research Center. We all know that DARC is one of the best institute where the whole work is done only on the nucleus. So this is a very good opportunity. By understanding just this topic as well as atomic structure and little bit with thermodynamics. If the students of chemistry as well as physics and mathematics, he just try to understand little bit about nuclear chemistry, little bit about atomic structure and little bit about thermodynamics, he will be definitely a member of BARC. BARC is one of the best institute in the world to work on the nucleus. So nuclear chemistry is just a branch of chemistry which deals with the study of structure and properties of nucleus. Or in simple language, study of nuclear particles, nuclear forces, and nuclear reactions. This is the basic definition of nuclear chemistry. In this structure of atom, whenever we are discussing about the nucleus, it means we have to understand what is meant by atom. So according to Rutherford, the atom consists of two main parts. Firstly, central part, and second one is extranuclear part. Atom consists of these two main particles, and its peripheral region, its extranuclear part. And nucleus contains protons and neutrons. Protons or neutrons are collectively called as nucleons. And the extra peripheral part, which is around the nucleus, is a extranuclear part, and that contains electrons. Whenever the nucleus is there, there must be a proton and neutron. With this, there are some terms like this: atomic number. Atomic number is nothing but a number of protons. Number of protons, whenever we are deals with proton is a unit positive charge having 1 unit mass. It means the representation of proton is proton 1, and atomic number is nothing but number of protons present in the nucleus. Next one is the mass number. Mass number is mass of nucleus, because as we already know that the atom consists of three fundamental particles, that is proton, neutron, and electrons. Protons are positively charged particles having unit mass. Neutrons are chargeless particles having unit mass, and electrons are revolving around the nucleus in a circular orbit having negligible mass. It means whenever there is a concern of mass, we have to keep in mind number of protons and number of neutrons, as these fundamental particles contains considerable mass. No doubt electron has mass, but that mass is very negligible. So whenever we are calculating the mass, it is mandatory to consider only the number of protons and number of neutrons. So mass number becomes mass of proton plus mass of neutrons. Then neutron number. The neutron number is again, the neutron number is a subtraction of mass number minus number of protons, because protons and neutrons are situated in the nucleus, and the mass number is proton plus neutron. It means we can easily sort out by simple mathematics rule. The number of neutrons is equals to mass number minus number of protons. So after that, we have some important definitions. That definitions are: what is mean by isotopes, what is mean by isobars, what is mean by isotones, and nuclear isomerism. Whenever we are deals with nuclear chemistry, the term isotopes is very important. When Mendeleev discovered his periodic table, then there is a major drawback of Mendeleev's periodic table is that he wouldn't find the perfect position of their isotopes, because his law states that the physical and chemical properties of an element are the periodic function of atomic number. Mendeleev told that the physical and chemical properties of element is a periodic function of atomic mass. We told that this periodic function is atomic mass, but later on it is found that this is the function of atomic number. That's why the drop of Mendeleev's periodic table is automatically ruled out. So here, these terms are very important because without understanding of these terms, it's highly impossible to consider the upcoming topics which were discussed later on. So firstly, isotopes. Isotopes are the atoms of same element. Atoms of same element having same atomic number but different mass number. This means atoms of same element indicate it has same atomic number. So compounds having same atomic number but different mass number is called isotopes. Oh, so the example of this is hydrogen 1,1, hydrogen 1,2, hydrogen 1,3, hydrogen, deuterium, tritium. This is the example of isotopes. It means isotopes are having say different number of neutrons. The isotopes are found just because of their difference in number of neutrons. Then the next term is isobars. Isobars is another very important definition we are frequently used in this nuclear chemistry. So isobars are compounds of different elements. In isotopes, we are deals with compounds of same element, but in isobars, we are dealing that compounds of different element, because here is carbon and nitrogen. Compounds of different element having same mass number but different atomic number is called as isobars. So the example is carbon C14 and nitrogen N17. This is 14. These two examples having same mass number but their atomic number is different. So this is the example of isobars. Now isotones. Isotones is another important definition. In isotones, what happens? There is a compound of different elements having a different atomic number as well as different mass number. Compounds of different elements having different mass number and different atomic numbers, but the same is number of neutrons. The same number of neutrons is called as isotones. So in this, the example is carbon C14, carbon nitrogen N15, and oxygen O16. So this is the example of isotopes. Now, nuclear isomerism. This is a little bit different definition, different term, which up to this level we can't hear this term nuclear isomerism, because in atomic structure, in previous topics we are a little bit familiar with the definition of isotopes, isobars, and isotones, but the nuclear isomerism is different. In this case, what happens? Compounds of different elements having different number of atomic number and different number of mass number. But what happens? They show different nuclear properties. They show different nuclear isomerism. It means their half-life period may be different. After emission, they can emit different kinds of radiations, and after emitting the radiations, the final product is different. Depending upon which constituent particles is bombarded on the target nucleus, there is a difference in their nuclear properties. This is called nuclear isomerism. And this is example. See, in this example, we firstly bombard a nitrogen, highly projectile nitrogen, on bromine 79. We will find krypton 80. And when we are bombarding with the same with the same projectile, that is neutron, on this bromine 81, we will find krypton 82. This is just due to their different nuclear properties. So these are the few terms which were frequently used in this nuclear chemistry. Isotopes, compounds having same atomic number but different mass number. Isobars, compounds having same mass number but different atomic number. Isotones, compounds having different mass number as well as different atomic number but having same neutron number is called isotones. And nuclear isomerism, it means compound of different element having different nuclear properties. It means difference in their maybe in neutron number, maybe in half-life period, and finally the radiation will be different their product and well as radiation. This is clear. Friends, we all know that we are something here and there. Too many activities we are doing. Yeah, number of activities are done. And the final is that after doing this, we are going in understanding that no one can do that. If we are after doing tremendous n number of efforts, by n number of efforts,
Hello. Hello, Kendre sir.
आवाज येतोय का माझा?
No sir. Sir, आवाज येत नाही.
आवाज आहे का?
नाही sir, नाही.
आता येतोय का? आता आवाज येतोय का सर माझा?
Sir, Kendre sir.
Sir.
Can you do one thing? You should off your video. You should off, and only you put your mic on unmute mode.
Okay, sir. Okay, sir.
I think the range is not proper there. That's you just do you put your audio video off.
Okay, sir. आता येतोय का सर?
Yes,
Hello?
yes. Yes, sir. Yes.
Okay.
Okay. You share your screen, sir.
Okay, okay. Is it visible, sir?
Yes, yes, yes. Clearly visible.
Okay, sir. आवाज पण येतोय?
Yes, yes. Very clear, sir.
Okay, okay. So, whenever we are dealing with nuclear stability, the main part is that the size of atom is very small. It is very teeny particle. The size is approximately 10 to the power minus 10 meter. This is the size of atom, and in that atom, the size of nucleus is 10 to the power minus 15 meter. And neutrons are tightly bounded. positive charge and neutron is chargeless. Proton having unit positive charge and neutron is chargeless. There is no force charge, and unlike charges, there is attraction between two unlike charges. And for direct product of gases, so distance is very small, and both proton having a positive charge, it means there must be a force of between these. That force of repulsion for nucleus unstable. Due to this force of repulsion, nucleus undergo instability. So whenever we are discussing these yes sir. हो सर.
सर का प्रॉब्लेम आहे, आवाज कट होत आहे तुमचा.
असं का?
अल्टरनेट नेटवर्क. हॅलो सर.
नेटवर्क बदल
तुमचा आवाजच येत नाही. हॅलो.
परत जिओ लावतो एक सेकंड.
हा, जे चांगलं नेटवर्क चालते तिथं तुमच्या तिथं ते ट्राय करा.
आता ओके केलंय. ओके सर, आता आहे का होता पडले सर?
नाही सर, नाही सर.
नाही का?
करा सर, कंटिन्यू करा, मी सांगतो तुम्हाला.
हॅलो, आता येतं का?
No, sir, still it is your voice is breaking now.
हॅलो.
आता
सर नाही, अजून क्लिअर नाही. कुठलं नेटवर्क तिथं जे सुटेबल आहे, म्हणजे चांगलं नेटवर्क आहे ते असेल तर बघा ना.
हो, आयडियाचं पण केलं आणि
अच्छा, मग अगोदर येतो होता आवाज. आता येते आवाज येतो आता क्लिअर.
हो,
क्लिअर येतोय सर आता आवाज. हे कुठलं जे नेटवर्क वापरताय त्याच्यात बोला सर, म्हणजे चालूच आहे.
माझा आवाज ओके आहे ना सर आता?
येस सर, येस. ओके.
ओके. Whenever we and ready and another is having, I know that for repulsion as well as
Sorry to interrupt you, sir. Kendre, sir, sorry to interrupt, but again some disturbances are there. Sir, unmute yourself.
रेंज पण फुल आहे सर, काही प्रॉब्लेम नाही आता.
असा आवाज येतोय तुमचा, पण
हा हा
टॉपिक प्रेझेंट करताना काय व्हायला की मध्येच ब्रेक करायला मला.
हा असं का?
आता फार क्लिअर आहे. आता तुम्ही बोलताय ना, क्लिअर आहे आवाज.
ओके, ठीक आहे ठीक आहे. ठीक आहे सर, करू का मग सुरू? परत एकदा स्क्रीन शेअर करावी लागेल का मला?
हो सर.
Then why nucleus is stable? It's explained on the basis of this is explained on the basis of number of protons and neutrons. Whenever the nucleus contains number of protons and even number of neutrons, the stability of nucleus increases. It means the nucleus is more stable. Whenever there is even number of protons and odd number of neutrons, the stability of nucleus is less compared to less and even number. And vice versa, it means odd protons, even number of neutrons, again the stability decreases. And when the nucleus contains odd number of protons and odd number of neutrons, the stability is very less. The factor why this nucleus is stable, this is explained on the basis of odd and even number of protons. Next one is the N by P ratio. N by P ratio or N by Z ratio. Scientists plot one graph for the stability. They plot number of protons, number of neutrons, number of protons on x-axis, number of neutrons on y-axis. They found that atomic number 20. Up to atomic number 20, whenever there is N by P ratio is equals to 1, the nucleus are stable. But when this ratio, this plot increases, there is a stability zone. There is a zone is shown as shown in this figure. The stability steadily increases and the value of this is 1.6. So when up to that stability zone, N by P ratio is greater than or less than equals to 1. This means N by pattern stability is when N by less than the stability decreases. In that case, that nucleus emits beta or emits electron, so on that is which one stability zone, they try to emit beta or positive so as to on that stability or that stability. scientists protons and of neutrons, number of protons on x-axis, number of neutrons on this. They found that ratio is that protons and neutrons are, whenever they found that N/P ratio is, then the value of N/P is more than 1. It means that number of protons in that nucleus are more. Number of protons in that case are less. Number of neutrons must be converted into number of protons by emitting beta particle. Whenever there is a ratio of N/P is less than 1, then number of proton must be converted into number of neutrons, and by emitting positron, that is counterpart of beta particle, we can easily achieve that stability belt and nucleus becomes stable. This is explained on the basis of N/P ratio. After that, magic numbers. Magic numbers are when scientists suddenly observe that if the nuclei contains number of protons or number of neutrons with a number of 2, 8, 20, 28, 50, 82, and the nuclei containing such kind of protons number, they show extra stability as compared to other numbers, so that they refer these numbers as a magic number. Because without a kind of reason, they dramatically found that these numbers, just due to the presence of these numbers, the nucleus is stable. That's why they assign that numbers as a magic numbers. Then another factor is packing fraction. Packing fraction is another term which is used for assigning the mass about mass is isotope is proper in way. We can find that isotopics, that isotopic mass number divided by mass number into the power. The Q indicates the if
Kendre sir,
Sir, you have to share again.
yes sir, yes sir.
please share your screen.
I think some network issue is there, due to which you are jumping out.
Yes, maybe.
Yeah.
But this is not happening today. Very all
Okay, sir. This is the actual drawback of this virtual classroom. Due to some network
Yes.
issues, we cannot do anything to this network problem.
What happens, sir? That link is break. That's why. Okay, no problem. This packing fraction value indicates
Kendre sir, do
stability
one
of
thing.
nucleus. Yes, sir.
Sir,
Yes, sir.
Sorry to disturb you.
No problem.
Yes, sir. Do one thing. Just convert your PPT into PDF. It will be run properly.
Okay.
Yeah. if issue is again there, then
Okay.
uh,
Okay.
yeah,
Okay.
okay.
Okay. Then, if the value of packing fraction is negative, the stability of that particular nucleus is more stable. Then another term, mass defect and nuclear binding energy. Firstly, we will discuss about mass defect. Mass defect is nothing but calculated mass minus observed isotopic mass. A very few seconds, we hear the term isotopic mass. We know that calculated mass is, it contains calculation of number of protons, calculation of number of neutrons, and calculation of number of electrons. This is the calculated mass. It means mass of one proton into number of protons, mass of one neutron into number of neutrons, and mass of one electron. Though it is negligible, but when we are calculating the mass as a calculated mass, we are calculate that mass in a mathematical formation, that is calculated mass. And calculated mass and observed isotopic mass, it means this is just a weighing mass. When as we already discussed, the size of nucleus is very small. This is only up to 10 to the power minus 15 meter. Due to this very small size, the bombardment of proton on proton, proton on neutron, neutron on neutron on neutron and proton. Due to this bombardment, there is loss in mass. There is mass, but mass effect. Actually, calculated mass must be to observed isotopic mass, but what happens? Due to this very small is a difference in calculated mass and observed isotopic mass, and that mass defect is responsible for the binding of that nucleus. As the mass defect is more, automatically binding energy of the nucleus is more, because Einstein already gave us a formula is equal to mc square. By keeping this in nuclear chemistry, the same aspect is there. More is actually 4 is because that defect into 931, this will increase the binding energy of that particular nucleus. Again, more is the loss of soil, more is the binding energy. And again, mean nuclear binding energy is nothing but binding energy upon mass number or its mass number. It means binding energy or mean nuclear binding energy is more doubt there is more that mass defect is by 90. Now the next is nuclear fission reaction. Nuclear fission reaction, the example is plutonium bomb. Nuclear fission word itself indicate that there is a fission. This means a splitting of heavy nuclei into two smaller fragments of approximately equal mass is known as nuclear fission. In this case, mass of these two found daughter nuclei is less. I already discussed about that more is the mass defect, more is the binding energy. It means energy and mass are correlated with each other by Einstein's formula E is equal to mc square. This is applicable here when a heavy nuclei by bombarding a newly found maybe neutron, beta particles, maybe gamma particles, that heavy nuclei splits into daughter elements. Ultimately, then the defect in mass is responsible to create a tremendous amount of energy, and this energy is used for many applicable appliances. So here is uranium, which contains 0.7% fissile isotope and 99.3% uranium-238 non-fissile. Of uranium-35 is in a combined state of various isotopes or various ore of uranium. We can't extract that uranium from it is we for that plutonium bomb, the start is U-38, which is really available. There is no need of efforts for taking extraction from its ore. Uranium-238 is easily available, and that uranium-238, by bombarding that nucleus by a neutron, we can convert that uranium into uranium isotope that is so plutonium bond fission reaction nearly is and difference.
Hello.
Sir, Kendre sir. Kendre sir, as per the suggestion of our IPSC coordinator, Dr. Arvind Chavan sir, you convert this
Okay.
PPT into PDF.
Okay.
And then we'll try, because lot of disturbances in your voice is there during presentation.
Okay.
Actually, your efforts are really good. Your presentation is good, and you are delivering such a nice topic. But due to that network congestion, we are facing a problem. So try
Okay.
once.
Okay, no problem. Do that. Hello.
हाँ सर. Yes sir.
येतो आज? ओके सर 3-4 पीपीटी आहेत, कन्वर्ट करत बसत नाही.
बरं असं आहे.
हा. Okay. The opposite word for nuclear fission is nuclear fusion, and the example is hydrogen bomb. We know that around the sun there is a plasma, and the sun is met and so energy for Earth, because all life is just due to the presence of that sun, and that energy which sun's atmosphere emits due to certain actions works on principle fusion. The fusion kinds of way, two molecules from helium, then two molecules of deuterium form isotope of hydrogen, deuterium, tritium, which emission of and emission sound sun here of response and emits amount of which were discovered by Henry Becquerel. So radioactivity is just an emission of active radiations by radioactive substances is called radioactivity. In radioactivity, radioactive substances spontaneously like and gamma to form a stable nucleus is called as radioactive substance, and the phenomenon is called radioactivity. So firstly, we will discuss about the characteristics of alpha particles. Whenever we heard the word alpha particle, we have to keep in mind helium nucleus. A helium nucleus is helium 2, it means 2 atomic. About this unit negligible mass, just like electron. And gamma particles are energy radiations. Gamma particles are having no mass and no charge. They are just energy radiations. Now, when radiation takes place, there is emission of alpha, beta, this is explained by displacement law. So this would
Sir, unmute yourself.
Applications of
Kendre
radioisotope.
sir.
In this industry, of which how many years of work, how many years of aluminum is easily use of radioisotopes. Underground isotopes reactions also use isotopes. Gamma rays used in many industrial reactions. In agriculture, these radioisotopes can be used in study of transport from roots and can be killed by radioisotopes. Use of irradiated seeds increase the yield and cause of rapid growth in plants. After irradiation, the yield of that seed and growth is increased by this due to this irradiation. In medicines, iodine is used in the treatment of brain tumor as well as for thyroid disorder. Sodium 24 is used to detect circulatory disorder. Cobalt 60 is used for the treatment of cancer. Phosphorus 32 is used in the treatment of leukemia. Last application of this radioisotope is, and most important, is carbon. The scientist W.F. Libby discovered this dating because we all know that we are all, when we are all living things are alive, there is exchange of carbon dioxide and oxygen through our respiratory system. The nitrogen 14, which is present in the atmosphere, inhaled by us, and there is a fixed proportion of carbon 12 as well as carbon 14. But when that living body is dead, there is a stop of absorption of carbon 14 and decay of 14 takes place. By measuring the decay of C14, we can easily calculate the particular age of that fossil, of that any living thing which contains carbon. This is useful for the dating purpose. So, may I stop here?
Okay, thank you, sir. I think we are in the last session. The session which is delivered by the young dynamic personality, Dr. Kendre sir, from Toshimal Arts Commerce Science College, Hingoli, Hingoli. Sir, I am very much thankful that you have tried your level best to deliver the content on the topic which is very important, but due to some technical errors, the session is somewhat interrupted in between. But somehow you have